Okay, so question 1, we're looking at the 2014 Exam 2 Extended Response. We're going to try and get it done in under an hour. Okay. The first one, generally speaking, this exam was, I think, very fair. It rewarded the hard workers, the people that knew the course. Unfortunately, the 2015 exam did not do that, the one we went through previously. There was quite a few tricks to it, and also there wasn't enough easy marks. I think if you knew the course, if you knew the skills, I think you would have done pretty well in this exam. But there was still quite a few questions which trip you up. Now, for this one, first of all, it's asking for the coordinates of the stationary points. Now, don't go ahead and do it by hand. It's not saying show that, is it? So I want to do f dash of x. Now, here's one I prepared in my calculator earlier, so you should be punching this away in your calculator. But I got minus 18 x minus 1 over x minus 4. You definitely need to write out what you got for the derivative. Okay, you need 3 method marks, so you need something. You can't just go ahead and writing an answer. So therefore, a stationary point, you know, we're letting f dash of x equals 0. So you still need to explain, you know, so therefore that's going to give us x is equal to 1, okay, i.e. 0 is equal to minus 18 x minus 1. So therefore, when x equals 1, f of x, we need to find the y coordinate, is equal to 9 over subbing that in. 1 plus 2 is 3 times minus 3, which is minus 1. So therefore, we have a single stationary point at 1 minus 1. That's it. Nothing more required. State the equations of the asymptotes. Well, you should know that this graph is going to look something like, you know, this. And we're going to have what becomes a minimum. It will be, when we do the reciprocal, will be a maximum. So we might have a graph which looks something like this. Now there's 2 asymptotes there, and that is that asymptote is at no working required here. X is equal to minus 2 and x is equal to 4. Obviously that is required, but we're missing an asymptote. A lot of people, students will probably forget that we've also got an asymptote of y equals 0. Okay, so there you go. There's your 3 marks. Don't go do anything more. There's really no need to. You don't need to show any working for that. It's asking us now to sketch the graph. Now I could sketch it in a calculator, but I think that's a bit of a waste of time. You should know what this graph looks like. We've got an asymptote. So this is from the reciprocal section. Let's label them. X equals minus 2, please, and x equals 4. Now, really, what you could do is in grey lead, you could draw x. You could draw the reciprocal if you like. You could draw, you know, x squared minus 2x minus 8. You could draw that. Don't forget the 9 though. And then what we could do is we could find the minimum. As it turns out, we've got a minimum at, we've got a minimum at 1/8, but then you've got negative 1/8. Then you've got to consider that 1 over that is going to be a maximum at minus 9/8. Okay, so let's get the shape right first of all. Now, by the way, we've got an asymptote here, so we've got to draw that. Okay, and then finally, what you need to do is you need to draw a graph which with asymptotic behavior approaches the asymptote. Be careful with that. No need to use your CAS calculators. And finally, we definitely want to mark our stationary point. That's at 1, negative 1, like here. Okay, so that's our stationary point. And what we have is we have something which looks like, there you go, with asymptotic behavior. The values coordinates with any intercepts So therefore, we need to label what these coordinates are. So we have a minimum, we have a maximum at 0, -9 on 8, and we have a maximum at 1, -1. I think that's about enough. No need for endpoints, no. No. Sketch the graph for -6. I wouldn't know. I don't think there's any need for endpoints. So they haven't said. Yeah, you would put a dot there. Yeah. No, I wouldn't. No. Now, the region bounded by, what we're looking for is we're looking for the volume is equal to pi y squared dx is our general form for rotating around the x-axis. Now, our value for y, though, is, y is equal to 9 over x plus 2, x minus 4. Now, we're looking, so therefore, all you need to do then, volume is equal to, all is required is we're going from, let's bring the pi out the front, 0 to 3, and we're squaring that, which is 81 over, we could do that a number of ways, x plus 2, x minus 4, there you go, squared. You could have something which looks different, but is the same. And that's it. Don't forget to omit the dx. Don't forget to, include the dx. And then the next point is we're just literally just subbing that into a calculator. Volume is approximately equal to, in 2 decimal places, I got 12.85 when evaluating that. All right, so that's question 1. We've done it in about, 8 minutes with some explanation. You should be able to get that done in much less time because question 1 generally be fairly quick. All right, don't take too long on those. If you take too long on the earlier questions, you'll find you'll start to run out of time. You've got to buy yourself some time. Okay, now I thought this was pretty fair, but there was some tricks to it, especially towards the end. We're looking at a complex number. First of all, in polar form, 2 marks, there needs to be some evidence of working. Okay, so I want to see that the modulus of Z1, that's equal to the square root of root 3 squared plus minus 3 squared, which you can then just evaluate in your head. You don't have to show any more than that. That's equal to 2 root 3, okay, or root 12, 2 root 3. Now, therefore, we've got to work out the argument. Now, theta is equal to inverse tan. This is my reference angle. We're looking at the y component, which is the imaginary, minus 3 over root 3. And that's going to be equal to pi on 3. But what quadrant are we in? We're in the 4th quadrant. So therefore, Z1 is equal to 2 root 3 cis of my minus pi on 3 is my argument. Dunskies. You should only take 30 or 40 seconds to do that. Okay? Now, it says find the argument of Z1 to the power of 4. Well, first of all, we know that Z1 to the power of 4 is equal to, who cares? It's 2 root 3 to the power of 4 cis of minus 4 pi on 3. But is that argument in the range of minus pi not inclusive to pi inclusive? No. So therefore, what we need to do is we need to consider that we need to add 2 pi to that. So therefore, arg of Z1 to the 4 is equal to minus 4 pi on 3 plus 6 pi on 3 is 2 pi on 3. That's, to be honest, if you knew that straight away and could work it out, that's all you required. Write that down. Write that down. Given that this is 1 root to the equation, find the other 2 roots. Now notice that this is 2 marks and this is exam 2. You could do all sorts of crazy things. Do they give you much room in this question? No. So what you need to do is you need to go back and you need to realise, hey, we did look at some things with complex numbers. In actual fact, we probably looked at things such as maybe C-solve, like that. C-solve, put it in, and then you go and spits out the roots. Okay, we've got Z is equal to root 3 plus 3i, root 3 minus 3i. Of course, they come in conjugate pairs. There's our conjugate pair, isn't it? And the other one, which is a real solution of minus 2 root 3. Okay, so we go ahead and we just simply write those out. So what we could say though, just to make sure that we please the examiner, we can say Z1 is equal to root 3 minus 3i, and we could say Z2 is equal to root 3 plus 3i, and I could even go conjugate root theorem. That'll show them that you know what you're doing. And then, of course, we can say that Z3 is equal to minus 2 root 3. No need to show any working there. You've got three things, two other things. I guess one will be an answer mark for each. Now it's saying find the value of this such that Z1 is equal to that. Well, it's worth 1 mark. So once again, no, doesn't say show anything. You know the answer, fantastic. But I do think you need to evaluate something here. If you try to skip too many steps, let's throw in root 3 plus or minus. So let's throw in the Z1 and its conjugate. That is equal to root 3 minus I times root 3 plus I. And that's going to be equal to 3 minus I squared, which is equal to 4. Stop. Now, we've just done that in part of the equation. It says show that the relation Z plus 2i, Z minus 2i equals 4 can be expressed in Cartesian form. It says show. A lot of you are reverse engineering and doing all sorts of crazy things. You end up getting 0 marks for that. First of all, what I'm going to say is I'm going to let Z is equal to x plus yi. Yeah? Now, if x plus yi, then I'm going to sub that in. That's x plus yi plus 2i. And then what we're going to do is and also we know that the conjugate is x minus yi. That's a very useful thing. Whenever you see that, that's what it is. The conjugate is x minus yi in general form. And that's minus 2i is equal to 4. So now let's collect our like terms. We've got x plus I, y plus 2. And over here we've got x plus I, or let's go minus I, y plus 2. Notice there that we've got like dots, don't we? Difference of 2 squares. So therefore, when I can get the terms, and when I expand it, I'm going to have an x squared term. Then there I'm going to have minus. It says show. So really, you can't skip too many steps. I would be showing this. I'd say minus y plus 2. And then that's times x. And then plus xi y plus 2. And then minus I squared y plus 2 squared. Show every step clearly, please. You've been given the answer. If you skip steps, you will not get the marks. Now, of course, you can then go like that. Examiners can see quite clearly what you've done. I squared is -1. So therefore, we have x squared plus y plus 2 all squared is equal to 4 as required. You can even sort of say since I squared is equal to -1, but I don't think you would need to do that. Okay, because you've been very clear. Now look, we've been asked to show that for a reason, because we're going to need it for later. You know, that's how these things work. So remember that if you're stuck on these things, think about what you've just done. Now, importantly, this relation here, we've just shown that, and the Cartesian equation is a circle. So that's what we're going to get. We're going to get a circle which is centered at, so the circle with the center of 0, -2 with a radius of 2. Let's draw my center and let's draw the edges of the circle, if you like. I wouldn't really call it an edge, but you can see, let's map it out like so. And here's our circle, like so. And that's it. There's 2 marks. Do you need to do anything else? No, no. Just a waste of time. Not needed. Okay. So there you go. There's a circle. No need to label it. Now, here's the tricky part to the question. The line joining the points corresponding to this, blah, blah, blah. K is less than 0 is a tangent to the curve. Pretty ugly, isn't it? But first of all, what we can say is, what is K minus 2i? K minus 2i is basically the Cartesian coordinate of K minus 2. Okay, that's the real and that's the imaginary part. And then we've also got another point which is minus 2 minus Ki. Is there a real part? No, so it's 0 and then that's minus 2 minus K. That's the first thing. Now, when I've got 2 points, we're looking for an equation. Let's find the equation of a line. So y equals mx plus c is my equation of the tangent. Okay, and let's find what m is for starters. So we can say that m is equal to my rise over run. If you like, we can say that, so I might get this thing, this can be y2, this can be x2, this can be x1. It doesn't look as nice though, does it? Because it's in terms of k's and things. But if you could then do my rise is y2 minus y1. That's going to be minus, oh look at that. So that's going to be quite nice for us. And x2 over x1, which is over k. So therefore, that's going to be minus, it's 0 minus k, which is minus k. That would be really easy to do. That's going to be equal to 1. So therefore, we've got y is equal to x plus c. Now, that's my equation of the tangent. But what we can say is, when x is equal to 0, y is equal to minus 2 minus k. I got that from over here. I just picked a point, picked the easiest point. I could have picked the other point as well, couldn't I? So therefore, my equation of the tangent is y is equal to x and c is equal to minus 2 minus k. Okay, now I'm going to call that equation 1 because I've got a tangent which touches some point. When it touches a point, it only touches, now obviously I've just drawn some random circle there, but it touches once. So I guess if you start to think about that, then you can start to think, well, if it only touches once, then I probably might have a quadratic equation. It could, yeah. No, it can only touch once. Tangent to the circle, so it only touches the edge and it will never touch any other point. Placing could be the other side, absolutely, yeah. We don't know where the placing is. We do know that k is negative. Okay, but we'll have a look at that in a second. Now, we also we know that the circle has the equation, is it x squared plus y plus 2 squared is equal to, what is it, 4? Okay, let's call that equation 2. Now, we don't need to find the answer to that, as far as we don't need to show any working there. It doesn't say show that. Okay, there's a fair few things in here. So what we do is we go to our calculator and we go ahead and we try and solve for that. Did I try that? I did. Now, I got this funny looking thing here. See how I tried to do it by the calculator and it just gave me all this jargon? So this was probably one of those ones where, okay, I've tried it in the calculator, maybe I'll just do it by hand. Okay, this might be one of those ones by hand. You get a feel for this the more and more exams you do. I can't teach you that. It has to be something which comes from all your exam practice. So what we're going to do is I'm going to replace y with x minus 2 minus k. So therefore we've got x squared plus x minus 2 minus k plus 2 all squared is equal to 4. See, that's convenient because we've only got x minus k now, all squared. So that's x squared plus x squared minus 2kx plus k squared. And I'm going to get the 4 over this side. So therefore, we've got this 2x squared minus 2kx plus k squared minus 4. Now notice that in the quadratic equation that would be c. K and A and B are obvious, aren't they? Now, what we want to find is we want to find k, but we know something, don't we? We know that this has only one solution. So the discriminant, which is equal to b squared minus 4ac, is equal to 0. B squared is minus 2k. B squared minus 4a, which is times 2, times c, which is k squared minus 4. Now, I would go ahead and I would work that out in a calculator. We could then go straight to the answer, which is k squared, is equal to 8. The question is then, what is k? K is equal to plus or minus 2 root 2. Which one is it though? It's one of them. Yes, therefore, since k is less than 0, we can say that k is equal to minus 2 root 2. As you can see, quite a few methods, quite a few things to get you 3 marks. That was a separated question. It is a lot for 3 marks, but hey, we've been doing this for 23 minutes. We've done about 24 marks, so we're on track, okay? We wasted a bit of time going through that, but we made up time doing other things. Because it says in the question, k is less than 0. Okay, now, let's have a look at this next one. I thought this was a really fair question. First of all, we want the vector resolute. Let's be clear of what you're doing. I'm going to say A parallel to B. I think that the examiner would be pretty happy with that. Now, of course, that's the scalar resolute times, I prefer this one, okay? It just works out easier for that one, okay? And that is A dotted with B is minus 3 times 2. Please show your working. 2 times minus 2 is minus 4. Minus 1 over 4 plus 4 plus 1, and that's vector B. Let's put that in 2i minus 2j minus k. Now, that is equal to 1 over 9 of 2i minus 2j minus k. Now, that is my vector resolute of A parallel to B. I don't know what you're talking about, dude. You can write it out, but no need to. Okay, we're just about. No, I want you to write it out. Yeah, absolutely, write it out, please. Now, A parallel to B. Now, remember, A parallel to B is, if we've got 2 vectors and I want one vector which is we've just found this. We've got the scalar resolute multiplied by a vector in that direction. This is vector A parallel to B. So if I'm going from here to here, if I've got the perpendicular vector, I've got to get this vector and I've got to subtract this parallel vector from my other vector A. So therefore, we can say that, and remember, it's not on the formula sheet. So A perpendicular to B is vector A minus our vector that we've just found. Okay, 2i minus 2j minus k. Now that is equal to 3i, I would be writing this out in full, ladies and gentlemen, plus k minus 2/9 I plus 2/9 j plus 1/9 k. Now that is equal to, I could go ahead and that's equal to 25 on 9i plus 20 on 9j plus 10 on 9k. No need for a calculator, but if you're mucking up your fractions and things, I'd be doing it in a calculator, but you're only wasting time if that's the case. You need to be pretty quick at evaluating. We are not done, by the way, because let's have a look at the question. It says, identify clearly the parallel vector resolute. It says, express, look at this bold thing, expresses the sum. So therefore, vector A can be expressed as the sum of two vectors, its perpendicular component and its parallel. So you would not get full marks until you say, therefore, vector A is equal to 1/9, if I 1/9 minus 2j, minus k, and then I added, well, I'm going to throw 1/9 out the front. That's going to be 25i plus 20j plus 10k. Done. And look, that was worth 5 marks. You could if you wanted to, but we are right. We've done that. Now, just quickly with this one, pretty straightforward question, I thought. AP, we want AP. Got to read the question. AP, we've got to go from, it's in terms of A and C. So AP is equal to alpha. Now AB is OC. Yeah, AB is parallel to OC. So therefore, we're going from OA what have I done? OB. So I guess that's AB plus a half BC. Could be a number of ways you do it. But either way, when you work that all out, basically what that is alpha vector C minus a half A. All right? Now, we've also got another expression for AP, and that is that AP is equal to or we can say that OP is equal to OA plus AP, which is equal to A plus what are we doing here? Yes. What did I do? Yep. AP is equal to AO plus OP. This is one of those ones I'm looking at the question and I did it yesterday. That's equal to negative A. That's right. And then what we're doing is we're simply just rearranging, and that we can see that AP is equal to beta A plus C minus A. And that's it. Now it says hence deduce. So what we've got is we've got two things for AP. So therefore what we've got is we've got alpha is vector C minus a half A is equal to beta A plus C minus A. Now what I would do is I would expand everything out, see what we've got and equate. So we've got minus a half A alpha is equal to vector A times beta plus vector of beta times vector C minus vector A. Now you can see here, look at the C's on the left-hand side and the right-hand side. You can see there that there is only one vector C, and we've on each side. So therefore, alpha is equal to beta. So now what I'm going to do is I'm going to replace alpha with beta, or beta with alpha. So therefore, we've got C alpha is equal to minus half A alpha is equal to A alpha plus alpha C minus A. Yep, cancel out the C's. And what we've got is we have 3 on 2 A alpha is equal to A. Therefore, alpha is equal to 2/3. There we go. We've got our answer. I didn't really like that question. I just thought it was a bit pointless. But anyway, then maybe that's just me. Just sort of like a little jigsaw puzzle almost. I didn't find it that useful though. Okay, now this one here, there was a point of doing like a specialist. One of which is we use similarity. And in methods and specialists, you may need questions like this, similarity, to actually get you started. You've been given the volume, so that way you can work it out later. But what we want to do is we want to find a relationship between the radius at any time when I have a height of h and r. And if you've done enough questions, you would have seen these. This has been a repetitive thing. It's come up repetitively. So if you're not all over the course, you won't get this done. That's one. So what I can say is I've got a ratio. You do need to actually show this. You need to show some evidence of where it's come from. You can't reverse engineer it, is what I'm seeing a lot of you do. What I'm going to say is I'm going to say that R is proportional to 0.5, which is a half. And then I'm going to look at the smaller triangle, which is H, is proportional to, H is proportional to 1. So therefore, R is equal to a half H. And I'm now going to, since the volume is of a cone is a 1/3 pi R squared H, which is a 1/3, and I'm going to replace R with a half H squared. Can you see there that the examiner can show, they know where you got the R equals a half H from. You've drawn your little diagram, you found your ratio. That is a 1/3 pi times 1/4 H squared, which is 1 on 12 pi H cubed as required. Yes, that's true. Yeah? Okay, now it says find the rate in minutes, meters per minute, at which the depth of the water in the tank. Whenever you see this, and you might sort of hack yourself, just have a look at what we are. What is the rates? We want meters per minute. We want dH dt when, I want you to write that. When h is equal to, I'll put a quarter. Okay. Now, once you do that, then we can then go, okay, well, we want dH, well, we've got a V in there, so dH dt, write it out like this. Our missing component is V. All right, like so. Now, so first of all, stop now, and we want to find dV dH. No need to do that in the calculator. You can do that quite easily, can't you? Bring that 3 out the front. That's going to be a quarter pi h squared on a quarter. Like so. Yeah? Okay, so now what we're going to do is, now dV dt is equal to, we're told that it, think about what happens. dV dt is equal to our rate in minus a rate out. Once again, it's worth 4 marks. You need to show evidence of this. Now, our rate in is, what is it, 0.02 pi. And our rate out, so we're subtracting 0.01 pi root h. I would be putting out my pi at the front, 0.02 minus 0.01 root h. Now, I can go ahead and express it, but remember we need to flip it and find dH dV. So therefore, dH dt is that flipped, which is 4 over pi h squared, and then that's times by pi. Well, that's convenient. We put pi out the front. Those pi's are going to cancel. dH dt. Now, what we can do is we've got a cas, so we don't have to go ahead and, when h is equal to a quarter, therefore dH dt, if I put that in the calculator as fractions, it would spit out 24 over 25, but it also 0.96 is also exact form, isn't it? Because there is no rounding off of decimal places, 0.960000. So yes, you can actually, either one of those would have been fine. No, because 0.96 is exact. There's no dot decimal point or anything like that. So 24 over 25 is exactly 0.96. That's why. That's right, exactly. Sorry? Yeah, so that's where, yes, they can have a decimal because it is still the exact answer. There's no rounding. Okay? Now, when the tank is empty at time equals 0, by using approximate definite integral, find the time it takes for the tank to fill. Now, we've just found an expression for dH dt. Okay, so if we have a look over, dH dt is our, what have we got? We've got dH dt is, we've got 4 over h squared, 0.02 minus 0.01 root h. Now, if you think about it, if I go ahead and flip this around, that will give me the time because it's asking for find the time. So what we can say is dT/dH, we've got a differential equation of which if I flip that around, that's going to give me that 0.02 minus 0.01 root h. Now, if I integrate both sides with respect to h, that's going to give me, so if I do that with respect to h, that's going to give me t on the left-hand side, and on the right-hand side, we've got h squared over 4, 0.02 minus 0.01 root h dh. By using it, find the time it takes for the tank to fill. Now, what is the total height? 1 metre, is it? 1 metre. So, therefore, that's going to give us the time it takes for the tank to fill 1 metre, which, when we evaluate in the calculator, is 7.4 seconds. Just quickly, what's our shortcut in the calculator to go straight to Shift plus? That's right. So we want to press Shift plus and get there straight away. All right, you'll be surprised how much that will save you some time. All right, we've got 19 minutes. Let's see how we go. What's that? Oh, yes, that's right. Sorry. I don't think they would punish you for that, but I wouldn't try it. Okay, 7.4 minutes. Okay. Now, they then ask this question here, which is worth 5 marks. This one, I thought this was fairly straightforward, but there was quite a few ways in which you can get slipped up here. Given the tank is initially empty, find the depth x as a function of time. So, first of all, what I would do is we want basically, what I'm thinking is, let's see, we want dx dt. Let's see if we can get dx dt. Let's use our related rates again. That's dx dv times dv dt. And let's work out what dv dx is. We can do that quite comfortably. dv dx, I'm going to differentiate everything which is inside there, which is 3x squared plus 12x plus 12. And then I've got a pi on 48 at the front. But I think we can simplify that a bit. Let's bring 3 out the front. 3 pi on 48. That's x squared plus 4x plus 4, which that's going to be pi on 16. And to make our life easier, that's going to be x plus 2 squared. So therefore, we can say that dx dv is the flipped version of that, which is 16 over pi x plus 2 squared. Now, we've got dx dv. What's dv dt? dv dt, isn't it coming in? Now, water's coming in, but it's not coming out. So it's rate in minus rate out, which is just, of course, the rate in. So therefore, we can say that dx dt is dx dv, which is 16 over pi x plus 2 squared times 0.05 pi. Well, 0.05 is 1 over 20, isn't it? And let's have the pi on the top. Okay, I haven't even touched a calculator yet. Can you see here? I think that this is probably, you need to have the skills in order to finish this exam on time. You really need to have these sort of skills with by doing it by hand. You can really waste your time on the calculator, punch things incorrectly and then pack yourself. Now, so that's going to be 4/5, so that's going to be pi, 4 pi on 5, x plus 2 squared. Now it's saying, given the tank is empty, find x in terms of t. Well, we've got a relationship. We've got a differential equation. Sorry, yes, the pi's cancel out. Thank you. Trying to do this way too fast. Okay, so I've got this. So what we're going to do is I'm going to flip, would make sense, because we've got a type 3 differential equation, dx dt, and we've got no t's. So let's flip it, dt dx. You can also do separation of variables, you guys know that. dt dx is equal to 5 on 4 x plus 2 all squared. Now let's do the integral of both sides. Therefore, t is equal to, let's do 5 over 4, and we've got 1 over x plus 2 squared dx. You could do that in your calculator. Trying to do things too quick again. So the x plus 2, we're on the clock, aren't we? X plus 2, I reckon we'll get there for sure. X plus 2 squared, is that better? Dx, okay. You will make mistakes if you go too quick. Trying to get this done in under an hour, okay? Now, do it in your calculator, but you should realise that t is equal to, that's going to be, we've got to raise the power by 1, cubed, and divide through by that power, and times by 5 over 4, and the derivative. That's it, isn't it? But we've got plus c. So therefore that's 5 on 12, x plus 2 cubed, plus c is time. Now, we need to find what time is, don't we? At t equals 0, what does x equal? Yes, that's correct. So 0 is equal to 8, 40 over 12. 40 over 12 plus c, well, that's the same as, therefore, c is equal to negative 10 over 3. So what we have is, therefore, time is equal to 5 over 12 x plus 2 cubed minus 10 over 3. Now, we want to find x in terms of t, so I would just go ahead and punch that into my calculator, or do it by hand. Yeah. So, yeah, that's right. If you try to put this in the calculator, it might go crazy. So what I think you should do, I guess what you could do, so you could go solve, if you went solve for all of that, comma, x, it might give you something that looks completely crazy. Why don't we just get x by itself? So t plus 10 on 3 times by 12 over 5 is equal to x plus 2 cubed. Now we want the cube root of that. We want the cube root of that, don't we? T plus 10 on 3 on 5, x plus 2. So therefore, what is it? X is equal to minus 2. Yeah. Yeah, that's right. That's what I did. When I put it in, the calculator didn't like it, so you'd have to do it by hand. Yeah. Yeah. Yeah, but we can't fumble around with a calculator to work out how to finally get it. I think you're better off doing it by hand. So look, your calculator will only help you to some degree. All right, look, I'm going to move on because I reckon I can get this done in 10 minutes before we're out. Quickly, when you're doing this, first of all, I've always said the 2 kilogram blocks going upwards. So let's label our direction of motion. Okay, we've got a 3 kilogram and a 5 kilogram object, of which the direction of motion, therefore, the direction of motion is this way for these guys. They're going that way. Remember that the direction of motion is, consider that as positive. That's what I've always told you. I've not told you that just to make your life difficult. I've told you that because you will make fewer and fewer mistakes by just doing that all the time. Not doing it your own way, following this process. Write the equation of the motion in the 2 kilogram block. Well, that means that T1 is positive because that's in the direction of motion. Minus 2G is equal to 2A. That is what we call an equation of motion, Jack. Okay? When you have your sack, you'll see why. This is an equation of motion. Newton's second law, force equals ma. I want you to resolve all of the forces and in terms of the acceleration. Do not solve it. Do not do anything. You move on. By resolving the forces each acting parallel to the plane on the other two blocks, write down an equation of motion for each. Well, 2 marks, don't have to go too crazy, but first of all, make sure you say, okay, 3 kilogram block, underline. I'm going to call this equation 1 because we might need it for later, and that is, be careful. We have a weight force which is going in the same direction as the direction of motion. So therefore, that theta, 3g sine theta, must be in the same direction. 3g sine theta. Trust me, if you don't do the direction of motion like I told you, you won't do that. Minus T2, there's no friction, is equal to 3a. Mass, which is 3 times the acceleration. And for the 5 kilogram block, then we also have the same thing. The weight force is going in the same direction as our direction of motion. Minus T1 is equal to 5a. And I'm going to call that equation 2 because I might need that for later. Maybe we'll call that, we'll just leave that for now. Yep. Yes, that's right. And because I've forgotten that. So T2 is going in the same direction as the weight force. So yes, T2. Thank you. I did write that in my notes, but I sort of just decided to omit that then, which wouldn't have been much fun. All right, so far, hopefully so good. Showing that the acceleration is. So what I'm going to say is, I'm going to say equation 1 plus equation 2. I'll say see previous page. I don't see why you couldn't do that. Why couldn't you do that? I don't see any reason. So what we're doing is we're adding those two equations together. So looking at the previous page, we had 3a plus 5a. So we've got 8a is equal to, we had 5g sine theta plus 5g sine theta plus 3g sine theta. And then I had a minus T2 and a plus T2. And then I had minus T1. They're going to cancel out, so we can say that 8a is equal to 8g sine theta minus T1. However, but since T1 is equal to 2a minus 2g, T1 is equal to 2a, is it plus 2g? Yeah, 2a plus 2g. Therefore, what we can say is that 8a is equal to 8g sine theta minus 2a minus 2g. So therefore, we can say that 10a is equal to, let's take out my 2g out as a common factor. That's going to be 4 sine theta minus 1. So look, there's a fair few marks for 1 mark, but you still need to show clearly. They do that because you'll need it for later. That's g on 5, 4 sine theta minus 1 as required. Go skipping steps, you won't get a mark, I promise you that. Find the angle theta for which is in equilibrium. Well, therefore, a is equal to 0. In your case, I'd be solving for 4 sine theta minus 1 is equal to 0. Comma 0, comma theta. But of course, you just need the answer, which when you work that out is approximately 14.5 degrees to correct to 1 decimal place. Okay, now this is, please, can everyone please pay attention to this one? It's asking us to draw a force diagram of these blocks. There's friction in play. And that friction has a value. This thing has, the thing on the left has a value of mu of 0.11. Okay, the first thing is, I want you to please label this as, because it's 3 kilograms, as 3g, please. Not force of gravity. That's wrong. It is right, technically, but we've been given 3 kilograms. Now, do not write the normal force here. I might call this the reaction force 1 because that's clearly going to be different. What I think if you do, if you label the other one as, or both of them as N or both of them as R, then you will lose a mark because they are not the same forces, are they? If you call that reaction force 2, examiner will not have a problem with you. Friction is opposing the motion. These things are sliding down the hill. So I'm going to call this 0.11 N, or sorry, R1. And I'm going to call this 0.01 R2. And I'm going to call this one 5G. There you go. That will give you your 2 marks. That was done really poorly. I'm talking less than 50% of students got full marks, which shouldn't be the case. All right, now let's proceed. Calculate the acceleration of the block down the plane. Well, that was pretty straightforward because we've got the equation of motion for each, but this time the equation of motion is different. 3g sine of 30 degrees minus our friction force, which is 0.11 times 3g cos of 30 degrees. You won't have those sort of questions anymore, though. I'm going to call that 3 times the, I'm going to call that A1, okay, because they block 1. So A1 is approximately equal to, on your calculator, 3.97. Please consider the accuracy, meters per second squared. And similarly, we've got 5g sine of 30 minus 0.015g cos of 30 is equal to 5a2. So a2 is equal to 4.82 meters per second squared. Now, our final question. This wasn't that bad. It says that these blocks collide, but there's 3 meters distance between them. So there's going, I'm going to call the distance that this first block slides, I'm going to call that X. Okay, and I'm going to call that the other one. So X, one slides 3 plus X, and the other one slides X. So what I'm going to do is for the 3 kilogram block, you know, we've got U is equal to 0, A1 is equal to 3.97 meters per second squared. The distance S is equal to X, and the T, well, both the T's are the same. For the 5 kilogram block, we've got the same thing. We've got U is equal to 0, A2 is equal to 4.82, S is equal to X plus 3. It slides down X plus 3 meters, and T is equal to the same. So what I'm going to do is I'm going to use my constant acceleration. X is equal to UT, which is 0 times T, plus a half times 3.97 T squared. Now, both those T's are the same. And also, we're going to call the other one is that X plus 3, which is the distance, is equal to UT plus a half times its acceleration times T squared. So therefore, what I'm going to say is, let those things, what I'm going to do, what I did is I got the X, I got X is equal to a half times 3.97 T squared, and the other one was X is equal to a half times 4.82 T squared minus 3. Therefore, I let those equal and solve for those thingies for T in my CAS calculator. And here's one I prepared earlier. No, I want that. I did actually do it somewhere. I got T is equal to, in my CAS calculator, I put it somewhere, of 2.66 seconds. T is approximately equal to 2.66 seconds. Okay, now look, we were motoring along, but it is possible to do that extended response in an hour if you really were motoring. Okay, now I'm going to just pause that video. There you go, we've done it under an hour.